Warm up number 55 is on the screen. Number 1 reads write in slope-intercept form and graph, and they give us 12 minus 3y equals negative 6x. Number 2 reads graph f of x equals x cubed. Then graph the transformation given g of x, which is g of x equals f of x minus 3 in parentheses, close parentheses, plus 2. Number 3 reads factor by grouping. Part A, x squared plus 4x plus 8 plus 2x. Part B, 2x squared plus 7x plus 6. Number 4, divide the polynomial with synthetic division. Polynomials given. 3x squared plus 16x plus 5 divided by x minus 2. And number 5, solve the system using substitution. So the system given is set notation. Inside of the set, we have x plus y equals 3 and x minus y equals 1. Hopefully you can do all 5 of them by yourself. I'll give you some time. Copy that and go. All right, let me make some space. For number 1, we're going to graph it using slope-intercept form. So first things first, we need to isolate y, leave y by itself. So that means I need to subtract 12, and we end up with negative 3y equals negative 6x minus 12. Divide by negative 3, divide by negative 3. So we end up with y equals 2x plus 4. I don't know, did anybody notice it was the same one from yesterday? Okay, good. We were like, what? So you're like so focused on the work that you didn't even notice. Nice. All right, so let's graph this one. Once again, it's called slope-intercept form because the x comes first and the constant goes at the end and the y is by itself. That's why it's slope-intercept form. So I'm going to start graphing this one using the y-intercept, which is 4. So we go on the y to 4, which is right there. And the slope, according to what's given, it's 2, the coefficient of x. In the fraction form is 2 over 1, which means 2 steps up, 1 to the right, and so on and so forth. And then you sketch your line going through there, like so. Now, could I use more points? Yes, I can. But for right now, I'm just going to use those. All right, next, number 2. It says graph f of x equals x cubed. Now, by now, hopefully you already know how to graph that without a table because we've been practicing, but now we're switching it off to cubics. So notice any function that we graph, a parent function always starts from the point of origin. Here, 0, 0. So what values do I usually use for graphing a parent function? Negative 1, negative 2, 1, and 2. So if I go to negative 2, what is negative 2 times negative 2 times negative 2? That's negative 8, which is down here. What is negative 1 times negative 1 times negative 1? Negative 1. 1 times 1 times 1, 1. And 2 times 2 times 2, 8. So the parent function of that cubic looks something like this. But they give us a transformation. G of x equals f of x minus 5 in parentheses. Applying this transformation to the cubic, I need to put the little cube right here outside the parentheses. And I need to rewrite this. So I write g of x equals, we no longer need the f notation, we just do parentheses x minus 5 cubed plus 2. So your noodle should identify which parameters we have in front of us. Is that correct? Look at it. Which parameters do we have now in this transform function? We have, Jazeel, which parameters?
I forgot the letters, but I know what they do.
Oh, what do they do?
So the 5 moves it to the right, or moves it to the right 5, and then the 2 moves it up 2.
That is correct. So, and also known, this is known as the H, and this is known as the K. Or in other words, what did we say both of them were called? The vertex. So now what is a vertex? According to what we said, 5 to the right, that's 5 positive, 2 up, 2 positive. So this 0, 0 of the cubic function is going to be at 5, 2, which is somewhere over here. 5 of x, 2 up. And all the points of that cubic function are going to move with it, and it should look something like that. Yeah, so we finished. I'll come to your, now that we've been seeing transformations already for almost a full year. Yeah, we're getting there, right? Now we're actually able to, you're like, I get it, Mr. Q, I know. Hello. It's like, hello? Yes. So you're like, okay, Mr. Q. Let's go to number 3. Is it in standard form? No. So first things first, let's write this in standard form. So I'm going to go, let me make some space right above here. So standard form, we rewrite this x squared plus 4x plus 2x plus 8. Let's group the first 2 and the last 2. First 2, last 2. GCF for the first 2 is x. We're left with x plus 4. GCF for the last 2 is 2. We're left with x plus 4. So what's the same here and here? Oh, x plus 4. And we're left with x plus 2. These are my factors. B, is there a GCF? No, but we have a leading coefficient, so we need to multiply that times 6. So that leaves us with 12 and 7 down here. Factors of 12 that add up to 7. So that is 3 and 4. So let me write this, 2x squared plus 3x plus 4x plus 6. Let's group first 2, last 2. GCF for the first 2 is x. We're left with 2x plus 3. GCF for 4x plus 6, that's 2. We're left with 2x plus 3. So my factors are 2x plus 3 and x plus 2. These are my factors. All right, let's go to number 4. Let me make some space right underneath here. So number 4, is it in standard form? Let's see, second degree, first degree, 0 degree, yes. First degree, 0 degree, yes. So I'm going to use this divisor, if I was to solve for x, we end up with positive 2. And we're going to use the coefficients here. We got 3, 16, and our constant, which is 5. Bring down the 3. So 2 times 3, that's 6. Combined, that's 22. 2 times 22, that's 44. Combined, that's 49. And we're done. That's our remainder. So this was in the second degree, first degree, 0 degree. But once we do the division, this is our first degree now. So this is 3x plus 22 plus our fraction is 49, our remainder, and our divisor, x minus 2. All right, and last but not least, number 5, we're going to solve using substitution. And this is a system. Why? Because there's 2 or more equations of the same variable. So what's the most important thing about solving by substitution? That we need to solve one of the equations for one variable. Do we have anything already solved? No. So which equation do you want to solve? Esmeralda, the top one or the bottom one?
The top one.
For which variable do you want to solve?
X.
For x. So Esmeralda wants to leave x by itself, so that means I subtract y. Subtract y. So my new equation is x equals negative y plus 3. So what does that mean, Mr. Q? That means that on the second equation here, instead of writing x, what am I going to write? Negative y plus 3. So let's do that. So I'm going to rewrite the second one, negative y equals 1. And instead of x, I'm going to write what? Negative y plus 3. All right, let's combine like terms. Negative y, that's negative 2y plus 3 equals 1. Minus 3 minus 3. Negative 2y equals negative 2. divide by -2, y equals 1. Are we done? No, Mr. Q, we need the other variable. When we solve a system, we need both variables solved for. So now we have y. We're going to substitute y over here. So it becomes 1. I bring everything else down. X equals minus plus 3. X equals -1 plus 3, that's 2. So we end up with 2 of x, 1 of y. That's my solution. But what does that mean? What does this solution mean? That coordinate. What do you think, Mia? What does that coordinate mean?
The intersecting point?
The intersecting point of both graphs. Let's go. Yeah, guys, so once again, when solving systems, we have to come up with a solution, which is where the graphs intersect, okay? Yes, Mr. Q? All right. So that's warm-up number 55. Let's move on. So our agenda, copy this down. We have warm-up number 55, which we already did. We have, today we're moving on to systems of equations. You're like, oh, Mr. Q, that's why you've been giving us practice. I know, right? Let's go. And then we got home play. It's only 2 pages, 197 and 98, evens only. And from there, we're done, adjourn. So today, we're only gonna cover a couple of examples. So your asynchronous code for tonight, here it goes. Nearpod code H4GUQ. 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 Okay. So your previous home play were these 6 problems and writing them in standard form and graphing them. Go ahead and turn those in on Canvas right now. Once you turn them in, make sure you get a Cornell note going. You do need a Frere model, and you need at least 2 coordinate planes from -10 to 10 on the domain and range. All right, and once again, reminder, home play for tonight is pages 197, 198, evens only, okay? So, I'll give you guys a little bit of time to turn in your home play, a couple minutes, and also to set up your Cornell notes. You need 2 coordinate planes, and then we'll get started. So I'll give you some time for that. Copy and go. All right. Is that plenty of time? Yes? All right, once again, make sure you have a Cornell note ready. You do need a Frere model, and you need at least 2 coordinate planes. We're gonna get started right away, okay? Here we go. So our objective for today, I can solve systems of equations. What kind? Linear and quadratic. I can solve systems of equations. What kind? Linear and quadratic, okay? So what's our main concept for today? Yeah, systems of equations, yes. What are we doing? We're solving them, okay. And what kind of systems are we looking at today? Linear and quadratic systems. Yay, right? Am I right? Am I right? So we're here like, Mr. Q, you're not all there. I think I am. I love this stuff. Ready? All right, here we go. So before I give you the definition on the Frere model, I'm going to take you back in time. Ready? To middle school, when you were first introduced to systems. And when you were introduced to systems, and not quadratic and linear, but they were just linear systems, there were 3 ways of solving them. They were by graphing, by substitution, and by elimination. So how many different ways? 3 ways. By graphing, substitution, and elimination. Now, those of you that were with me I'm pretty sure you remember these because I gave you a pop party where you had to solve it 3 different ways. You guys remember that? Some of you, yes? You're like, yeah, I think I remember, Mr. Q. Some of you that were not with me, hopefully you got plenty of practice with these. However, today, guys, pay attention to this. We're not going to solve it all 3 different ways. I want us to solve it at least by graphing and substitution. And repeat that again, by what? Graphing and substitution. That's why we did plenty of practice on the warm-up, remember, for 2 weeks with substitution method. Yes, Mr. Q, thank you very much. You're welcome. I got you. So, how many different ways? 3 different ways for the system. Now, since today we're dealing with quadratics, let's see, let's think back. All year we've been solving quadratic equations. Think about it. How many different ways do you remember solving quadratic equations? And yes, there's 5 different ways. We've already done all 5 of them. Do you remember all 5? Some of you like, forgot, Mr. Q. Okay, here they go. The first one that we've been doing most often is completing the square. Yes. What's the other one? Your favorite? Quadratic formula. X equals minus b plus minus square root b squared minus 4ac over 2a. Also graphing, also square roots. And the last one that we're going to be doing today, focus guys, the one we're going to use today is by factoring. You guys remember factoring? Yeah? Is that ringing a bell? Yes, Mr. Q. All right, so those are the different ways that we have solving quadratic equations. Since we have today's system with quadratics, we need to remember these 5 methods, but today we're going to focus on factoring. Everybody got it? Once again, make sure you remember those. So let's get started. For your model, what are systems of equations? Systems of equations. Let's see, did anybody catch what systems were? I've been saying it on the warm-up. Who's caught it? Who's got it? Let's see. What did I say system with? All right, very good. The set of 2 or more equations with the same variables. The set of 2 or more equations with the same variables. So what are systems? The set of 2 or more equations with the same variables. Systems of equations, the set of 2 or more equations with the same variables. Systems of equations, a set of 2 or more equations with the same variables. The set of 2 or more equations with the same variables. The set of 2 or more equations with the same variables. The set of 2 or more equations with the same variables. The set of 2 or more equations with the same variables. The set of 2 or more equations with the same variables. The set of 2 or more equations with the same variables. The set of 2 or more equations with the same variables. You're like, I got it, Miss Q. Well, I asked earlier, you didn't get it. So hopefully now you got it, right? Examples. We are given a set notation, then we got 2 equations. The first one, y equals x squared plus 5x plus 6. The second equation is x minus y equals -3. Another example is set notation, and inside we have y equals 3x equals 0, and y minus 6 equals -3x squared. Those are examples of systems of equations. Copy that. I'll wait for you. So, once again, definition, set of 2 or more equations with the same variables. So let's look at the first example. Is it 2 or more equations? Yes. Do they have the same variables? Yes, x and y, x and y. Second example, 2 or more equations? Yes. Same variables? Yes. All right, copy this non-example. There it is, non-example, set of x plus y equals 3 and a minus b equals 1. As you're writing it down, think to yourself, this is not a system of equations because blah, blah, blah. All right. So, Victor, why is that not a system?
Because they don't have the same variables?
They don't have the same variables. All right, that is correct. So let's get a couple of hashtags. Systems of equations. Hashtag what? Hashtag what makes them a system? Hashtag what? Hashtag what? You got the first one. What is the most obvious thing that makes them a system?
Same variables?
Same variables, thank you. What else is obvious that makes them a system? Hashtag what?
2 or more equations.
Bam, 2 or more equations. Thank you. All right, so now that we're clear as to what systems are, let's go and solve them. Yes? Yes, Mr. Q. All right, let's go straight to it. Example 1. Copy this. It reads, solve the system by substitution and graphing. And we are given the set of y minus 6x equals x squared plus 5. And the second equation is y minus x equals 1. Copy that. I'll give you some time. Make sure you set up your coordinate plane if you haven't from -10 to 10. We're going to be solving that 2 different ways. Copy that. And I'll come right back. All right, here we go. Y'all ready? Yes, Mr. Q. All right, so once again, when I ask you to put your utensils down, writing utensils down, just stay focused, and I'll have you copy right after. I want to make sure that everybody's following along as I'm going through these 2 different methods of solving. Okay, here we go. So writing utensils down, look up to the screen. So it says solve the system by substitution and graphing. So right now, I'm gonna look at what I have. Looks like I have a quadratic equation and a linear equation. Why do you know, Mr. Q? Well, the first one has the highest degree is 2. The other one does not have an exponent, which tells me if it has a variable that it's to the first degree. It's a linear. Okay, so first things first. I'm gonna solve this system by substitution. Now, what is the first thing I asked you to do on the warm-ups when solving for substitution to look for? That one of the equations is solved for what? One variable. So I'm going to take the smallest equation here, which is this linear, and solve for one variable. And I'm going to solve for, let's solve for y. So if I was to leave y by itself on the second one, that means I would add x to each side. So that leaves me with y equals x plus 1. Copy that. All right, so now that we have the second equation equal to y, why is that beneficial, guys? Because if we're gonna substitute, now we can substitute this equation into the other equation. Look up. The other equation has a y right here. Do you guys see that? Which means we're gonna substitute what value in there? The value of y. What is y? X plus 1. So I'm gonna bring this equation down here, and I'm gonna write, check this out, x plus 1, which was what? Y, and then minus 6x equals x squared plus 5. Copy that. Some of you are like, Mr. Q, where did you get x plus 1? So once again, originally it had a y there. You see this? Y minus 6x equals x squared plus 5. But now that we know what y is, what is y? X plus 1, which is there. We substitute that. That's why it's called substitution method. All right. So next, can we combine on the left side? Yes, let's combine the left side. Here we go. Let's see. X minus 6x, that's negative 5x. Bring down the plus 1 equals to x squared plus 5. All right, so now we have a quadratic equation. Let's think back. and all the practice that we did with quadratic equations, in order to solve a quadratic equation, what is the one most important thing that we need to have? It needs to be equal to what? Bam, Jaziel, let's go. Yeah, equal to 0. So we already have the x squared and the 5 on this side. That means we need to make the other side 0, which means what do? I get rid of the negative 5x and the positive 1 by doing what? Plus 5x minus 1 plus 5x minus 1 to each side. So that is 0 equals x squared plus 5x, and 5 minus 1, that is 4. Is it equal to 0? Yes. Is it a quadratic equation? Yes. And at this point, we would decide which method to use, but I said today, in order for us to solve this quadratic equation, we're going to use factoring. So we got 4, we got 5. Factors of 4 that add up to 5. Yeah, 4 times 1. What is 4 times 1? 4. What is 4 plus 1? 5. So we end up with 0 equals, so open to parentheses, the x squared, this one, becomes x times x. And what are the two values that we came up with? Positive 4 and negative 1. I mean, positive 1, sorry. Positive 4, positive 1. Okay. So let's see if your noodle kicks in right here. We have two factors here, equal to 0. What do we do to finish solving this quadratic equation? What do? Who's got it? Who remembers?
Make them equal to 0.
Let's go, Danny. Let's go. So we write x plus 4 equal to 0 and x plus 1 equal to 0. Yeah, so let's solve. Minus 4 minus 4, x equals negative 4. Minus 1, x equals negative 1. All right. Now, before, when we just solved quadratic equations, we would be done up to right there. But this is not a regular quadratic equation. Look up. We combined these two equations to become one quadratic equation. So what does that mean? That we still haven't finished solving the system. To solve the system, now we need a what? A y value. We need a what? A y value also. So that means, look up, guys. Let's bring this equation down. And we need to substitute what values? The x values, negative 4 and negative 1. That means I'm going to write this twice. Y equals x plus 1. Y equals x plus 1. Why did you write it twice, Mr. Q? Because we have two x values. One, I'm going to substitute here negative 4. And on the other, I'm going to substitute negative 1. They're right here. So y equals negative 4 plus 1. So what is negative 4 plus 1? Y equals negative 3. So, look up, when x is negative 4, what is y? Negative 3. Okay, so let's do the other equation. Y equals negative 1 plus 1. What is negative 1 plus 1? 0. So, what does that mean? When x is negative 1, what is y? 0. These are my solutions. All right. Question. If those are my solutions to that system, what does that mean? Think about it. What does that mean? What do those 2 points or those 2 solutions mean? What do you think, Angie?
It's where they intersect.
It's where the 2 graphs intersect. Bam, let's go. Once again, guys, listen to what Angie said. These 2 are where these 2 graphs, if once we graph them, they're going to intersect at those 2 points. So according to what we came up with, let's plot those 2 points. Check this out. According to what we said, these two are my solutions, which means that those two coordinates, -4, -3, and -1, 0, are where those graphs are going to intersect. We're predicting that. Okay. Are we there so far? All right. So show me your fingers. How come you are with substitution? 5, 5, 5, 5. Okay. Yeah, 5 fourths. Okay. All right. So we're done with substitution. Now we're moving on to graphing. Let's move on to graphing.
Wait, Mr. Q, I have a question.
Yes.
How do you know which point is which? Like, why is it -4, -3, not -4 or 0?
Okay, because that's a good question. So watch. We substituted -4 in here. Is that correct? And what did we get? -3. So that's why we pair it with that. So when we substitute -1 into the second one, what pairs with that one? 0. So yeah, if you want to sketch arrows so like that you can guide your notes, that's fine. All right. All right, so let's go into graphing now. For graphing, guys, I'm going to go ahead and get us started with what we usually do for graphing. For graphing, guys, look up. Make sure these two equations are equal to y. Make sure the two equations are equal to what? Y. Okay, so look at the first equation. Y minus 6x equals x squared plus 6. To make that equal to y, what do I do? What do you think, Octavio? To leave y by itself on the first equation, what do I do? Roman, help him out.
Do you add 6x?
Add 6x to each side, add 6x. So our new equation for the quadratic is y equals x squared plus 6x plus 5. Okay? And this one, the second one, we already had it in y form, which is this red one. I'm going to leave it like that, so I'm just going to write here y equals x plus 1. Okay, so which method are we using? We're graphing. Okay, so question, do we know how to graph this linear equation right here? Yeah, where do we start? Very good. We start at the constant, which is +1. What does that mean? That's my y-intercept, +1 right there. Next, we need a slope. That's why we wrote it in slope-intercept form. What's my slope? What's the coefficient here? It's an invisible 1. In fraction form, that's 1/1. What does that mean? 1 step up, 1 to the right. So let me do that. 1 step up, 1 to the right, 1 step up, 1 to the right, 1 step up, 1 to the right, 1 step up, 1 to the right. Do as many as you can. Get your graphing tool and sketch your line. Now, do you guys notice that that line actually goes through the 2 points that we came up with as a solution? Do you guys see that? Yes, Mr. Q. All right. So now all we have to graph is the parabola, the quadratic equation, to see if it intersects that line. So check this out. To graph, I'm going to make a table over here, x Why? Don't fill in the domain yet. Let me address something really quick. All right. Look up to the screen, write your utensils down to make sure you understand this part. Ready? Usually I would give you what domain? -2, -1, 0, 1, and 2. Is that correct? Yes. I'm not going to do that today. Why not, Mr. Q? Well, look up to the screen or you're going to miss it. Where are the solutions to the system located? Here and here. At what side of the 0 is it located? To the left. You guys see that? That they're to the left of 0? So if I was to use -2, -1, 0, 1, 2, that means over here, there's nothing over here, even if I graph whatever over here. So that means I need values for my domain for this side. Let me highlight it so you guys can see it. Some of you are looking at me like, what are you talking about? Here's 0 of x. Here's this solution according to us. And here's the other solution. So which values would we use? Any values from this side. So instead of using -2, -1, 0, 1, and 2, I'm going to move it over this way. And I can start at -5, or I can start at -6. Where do you want to start? At -5 to 0 or -6 to 0? What do you guys want to do? -5? Okay. All right, let's do -5. So fill in your table, -5, -4, -3, -2, -1, and 0. All right, so let's do the computation. I'm going to write this right here again, but instead of x, it's parentheses squared plus 6 parentheses for x plus 5. All right, I'm going to show you the work for the first ones, and then we're going to do the rest with our noodle. Here we go. I'm going to substitute the first value, which is -5, -5. So what is -5 squared? That's 25. What is 6 times -5? That's -30. Bring down the 5. Combine like terms. What is 25 plus 5? 30 minus 30, 0. Next, y equals parentheses squared plus 6 parentheses plus 5. Next value is -4. So what is -4 squared? 16. 6 times -4 is -24 plus 5. Combine like terms. What is 16 plus 5? That's 21 minus 24. That's -3. Okay, next. Y equals parentheses squared plus 6 parentheses plus 5. My next value is -3. -3. Y equals -3 squared is 9. 6 times -3 is -18 plus 5. 9 plus 5 is 14 minus 18. That's -4. Next, y equals parentheses squared plus 6 times x or parentheses plus 5. Next value is -2, -2. So y equals 4, -12 plus 5. What is 4 plus 5? That's 9 minus 12. That's -3. Now look up. I think we can get the next number without doing the computation. 0, -3, -4, -3. What's the next value here?
Zero.
Yes, 0. And the last one, 0. Check this out. If I substitute 0 here, that's 0. 6 times 0 is 0. That leaves us with 5. All right, let's plot those points. -5, 0. -4, -3. -3, -4. -2, -3. -1, 0. and 0, 5. Let's graph that. Point to here. Point to there. Let me do that a little bit thicker. We're going to point to here. We're going to point to there. And we're going to label that what? Solutions. What are my solutions? This one is -4, -3, -4, -3, comma. What's the other one? -1, 0. Why are those solutions? Because that's where what? The graphs intersect. Bam, let's go. How we doing? Good, Mr. Q. All right, so from 1 to 5, how comfortable do you feel solving a system of quadratic and linear equations by substitution and graphing? 5 4s, 5 4s, 4 4 4 4, 5 4s, couple 3s. Okay, yeah, we need practice, yeah? All right, let's do another one. Here we go. Y'all ready? All right, so that was example 1. Here goes example 1Q. I'm gonna give you a head start on this next one. See how you do. Just to recap, we were given a system of quadratic and linear equation. The first method was by substitution. We needed to solve one of the equations for y. We solved the linear for y. Substituted that into the second equation. From there, we simplified or set it equal to 0, factored, solved. That was x. Then we substituted those x values to the linear equation to get our y. And that's how we found the solutions. For graphing, we needed to set both equations equal to y. The linear, we can graph by using the slope-intercept form, slope-intercept, there it is. And then from there, we got the quadratic by using the values once we saw the solutions where they were going to be. Okay, all right. Example 1Q, copy this one. Solve the system by substitution and graphing. System y minus 6 equals x squared plus 5x, and y minus 3 equals x. Copy that and go. I'll give you a head start for that, and then I'll come right after to see how you did. Ready, go. All right, let's see how we did. Some of you should be done with substitution method, and you are probably starting to do your graph. Let me set this up really quick. All right, first things first. Set one of the equations equal, or solve one of the equations for one variable. Hopefully you solved the second one for y, so you added 3 to each side. And that left us with y equals x plus 3. From there, you took the first equation, you rewrote it. However, instead of starting with y and then minus 6, you start off with x plus 3, because x plus 3 is y. And then minus 6 equals to x squared plus 5x. From there, combine like terms on this side, we end up with x minus 3 equals x squared plus 5x. To solve that quadratic equation, you need it to equal to 0. So that means we need to get everything to one side. So minus x plus 3 minus x plus 3. That leaves us with 0 equals x squared plus 4x plus 3. From there, we're going to use the method of factoring in order to solve that quadratic equation. 3, 4 underneath, factors of 3 that add up to 4. Well, that's 1 times 3. All right, so from there, 0 equals parentheses times parentheses. X squared is x times x. And the two values that we came up with is +1 and +3. And what did we say we do with that? We set them equal to 0. So we have x plus 1 equal to 0, x plus 3 equal to 0. We solve for x, minus 1, x equals -1. This one minus 3, x equals -3. Are we done? No. We bring down the linear equation and we write it twice. Y equals x plus 3. Y equals x plus 3. Why twice? Because we're going to substitute -1 for x on one and -3 for x on the other. So we got y equals -1 plus 3. -1 plus 3 is 2. So this one is -1, 2. My solution so far. The other one, I have y equals -3 plus 3. What is -3 plus 3? 0. So when x is -3, y is 0. These are my solutions. All right. So far, so good? Hands, have you got that? All right, good. So let's plot those. So we have -1, 2, and -3, 0. So according to the solution, according to the graph, that's where they're going to intersect. Next, that was substitution method. Let's do graphing method. What is graphing method? So we need to set it equal to y. So this one we add 6 to each side. So that gives us y equals x squared plus 5x plus 6. And the other one's already in y form. So I write it as y equals x plus 3. So to graph the linear, we start with +3. That's our y-intercept, which is right here. Our slope is the coefficient of x, which is 1 over 1 in fraction form. So that's 1 up, 1 to the right, 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 1 up, 1 to the right. We graph our line. And so far, it is intersecting those 2 points. So let's get a table for our quadratic equation. And by looking at these 2 points, what values are we going to use for our domain for this table? What do you think? Nathan, what values do you want to use for the domain according to what we have predicted here?
I'd use from -3 to 0.
-3 to 0?
Yeah.
Let's do one more. Let's go over to -4 to 0. Thank you. So let's do from -4 to 0. So -4, -3, -2, -1, 0. All right. So if we write this equation, I write y equals parentheses squared plus 5 parentheses plus 6. So I'm not going to substitute it in there. I'm going to do it in our, I mean, you can do the work, but I'm going to do it so we can go a little bit faster because of just for the sake of time. If I substitute -4 in here, that's 16. -4 times 5, that's -20 plus 6. So 16 plus 6, that's 22 minus 20, that's 2. Next one, -3 squared is 9. -3 times 5, that's -15 plus 6. What is 9 plus 6? 15 minus 15, that's 0. Next one, -2 squared is 4. -2 times 5, that's -10 plus 6. That's 4 plus 6 is 10 minus 10, that's 0. -1 squared is 1. -1 times 5, that's -5 plus 6. That's 7 minus 5, that's 2. And 0, 0, that leaves us with 6. Let's graph that. -4, 2. -3, 0. -2, 0. -1, 2. And 0, 6. Let's graph that from left to right. There it is. So that means that we point to these. And those are solutions. which are what? 3, 0, and -3, 0, and -1, 2. Did we get that over here? Yep. All right, guys, I'm gonna stop right there. That's the home play for tonight. Basically, you're just gonna focus on substitution and graphing. Enjoy your home play, tutoring right after lunch. Be there or be elsewhere. Have a good one. Peace. Bye.